Welcome to the presentation of MPAI Metaverse Model Architecture. Our standards are called with MPAI dash a three-letter code, and MMM is how we call the MPAI Metaverse Model Architecture is a part of the set of specification that we are producing. So you may ask why MPAI has a business with the metaverse, and the simple answer is that, well, metaverse can be considered as the ultimate step in a process that lasted about 30 years. You should remember that about 100 years ago, a man called Nyquist was working on the digital representation of signals, actually. So he has his known theorem. Then the next point is that the design of metaverse requires many sophisticated media coding technologies. And so, because of that, let me continue with the answer. Industry is interested in the metaverse. Standard and artificial intelligence are considered as the main drivers for the development of the metaverse. And the MPAI has a foot in both areas. There are many standards that are needed, and we do have some of them that could be relevant. And the metaverse requires more standards in addition to those that exist. And again, MPAI has technology, and if they are not sufficient, we can develop more. The first question that I ask is, what is the meaning of metaverse interoperability? So we have several types of interoperability. The simple one is simply you have a standard format. You define syntax and semantics of the bits on the wire, and that is what you need. In the case of the metaverse, however, things are much more complicated because technology is evolving fast, and technology can have many different shapes. So we introduce mediated interoperability, where you have two different metaverse instances, we call them, each using a format, and you have a server in between that knows both formats and can make the appropriate conversion. But even though this is the first step toward the solution, conversion services do not guarantee interoperability for all cases, and this is why, because this conversion is not always possible because of this reason. So the first one is when we have direct interoperability. But then if you have a metaverse that uses certain technologies, then you can assume that for some of this data, it's possible to make a conversion, but in some cases, the data that exists in one metaverse do not map directly in another metaverse. That's why mediated interoperability is not sufficient. We should develop the requirements of the data that are provided by the two instances, and also the operation model of that image. So it's not sufficient to know what is the data, but should also know what is behind the creation of that data. That's why we introduce a functional interoperability, because if you know the functional requirements of the data used by one metaverse instance and the other, then you can have a lossless conversion. So what is the scope of this standard? Is to enable interoperability of two or more metaverse instances if they rely on the operation model that is part of the standard, use the same profile architecture. I will elaborate on the notion of profile, and if they use the same technology, that's good enough. But if they use independent technology, then they can use conversion service that can actually perform lossless transformation of the data, because we know the functional requirements of this data. A note, but this will become more clear when I will develop more the notion of profile, is that if the profiles are not appropriate, we may not have a full interoperability. But the profiles are designed in such a way that as to maximize this interoperability. So this is the table of content of the MPAI MMM architecture. So we have an introduction, we have the scope, one that I have presented, we have definition and normative references. Then we have functionalities and operation model. Then we have the functional requirements of 4 entities, process, action, item, and data types. Then we have a scripting language. We have use cases, and then we use the scripting language to analyze the use cases. And then we have the notion of functional profile that I will develop further. Now, what is interesting is that you have this standard fully available from the web. So for instance, if I click here, you will be taken to the chapter that is called functionalities, where we have a number of entities that are defined here. What are the rules? What is location? What is a persona? What is rights, which is very, very important, and so on and so on. But let me go now to the functionality of the MMM architecture. So we have definition of a metaverse instance, definition of processes, rule, registration, rights. We have general right, perception right, interaction right, service access right, and acquisition of rights. Then we have persona. Persona are the avatars, of course. Then how do you indicate a location in the virtual world and in the real world? What are objects and scenes, and what are identifiers? So of course, everything in the metaverse instance is identified. So let me go quickly to the notion of rights, and again I will go to the website. So we have general rights, as I was saying. What is the maximum number of users that are accepted? What the ability to create scenes, which means combination of objects. I mean, this thing. Then we have perception rights, in the sense that a user may perceive certain things, not necessarily the thing is on the web, but you may have the right to perceive it. You may also have the right to interact, or you may not have the right to interact. You have the right to access a service, and here are the things that you need in order to do that. And yeah, acquisition of rights. Okay, you don't have the right. How do you acquire the right? So this and then we have other elements here: the avatars, the locations, the objects and scenes, the identifiers. And with that, I can move to the next topic, which is the and that means that the operation model. As you see here, we have a number of requirements that we wanted to identify in order to specify the features of a metaverse instance, so that it can interoperate with another metaverse instance. So we have the notion of capabilities, the subdivision in the metaverse environment. A human can register, and the metaverse requires a subset of the personal profiles. Then this is important in the sense that a metaverse instance is implemented as a set of processes. And here you have the metadata that can can be used, have to be used in order to give the necessary information about a process. So I would like to dwell a little on the idea of the rights. These rights, the in rights, are the rights that are inherent in a process, and out rights are the rights that the process has and may give to others at certain conditions that are described in a license. Then again, we have a process can communicate with another process. We have a standard protocol whereby we have a set of data that are sent, and here is a set of data that is provided as a response. Then let's move on. Okay, so here we have the generalized view of the interoperability between metaverse instances, because you have a metaverse instance and another metaverse instance. Now a process is in a metaverse instance and wants to have a process in another metaverse instance to do. So here we have the protocol. So this is based on a resolution service that is a service that has the necessary capabilities to communicate information with another resolution service of another metaverse instance. And then we also need the conversion services, because the data that you send to the other metaverse instance are not necessarily understood, and therefore you may need a conversion service. We have identified 4 types of process. One is the device. The device is not the physical thing. It is the process that runs on a device. Then we have user, and user is a key element, because a user represents a human and is under control of a human. Then what is important is that what exists in the metaverse is the user. People think of the avatar in the metaverse, and this is not correct. What exists in the metaverse is a user, and then a user may or may not be rendered as an avatar. So we have clear this distinction. Then we have service, application, and so on. So this is what I was saying before. Here we have the user, and here we have the human, and here we have the user. Then the human uses a device, because the device is the entity that connects the real world with the virtual world. Then a user may be rendered as an avatar, or a user, which is a process, may connect with another process using the standard protocol that I have briefly described before. So here are the minimum set of metadata that I used for a process. Then we have several other points that, of course, the process and items are identified. Items can be created according to a process. Either they are created internally in the metaverse, or they are imported from the metaverse. And in any case, before they have citizen rights in the metaverse, they have to be converted into items and identified. So there are a number of data types that are used for certain purposes. These are not items; these are data types. And then it's possible to give a human the right to deploy users on the devices and persona. So these are critical elements, and therefore there's a specific right that is used to enable users and devices to do things, and also establishes the rules that govern the metaverse. Then a metaverse may penalize users, may allow a process to to perform some actions, even though it does not have the rights, because rights are forfeited in this case, or may require a process that certification of a process. And in the future, we have left the room to provide necessary extensions. Let me now go to the functional requirements of processes. So we have an app, a device, service, and users. I will just introduce briefly the requirement, the functional requirements of the device. So what is a device? The device is a process. It's not atoms. It's a process. It can capture data from the real world and can send the data to a user in the metaverse, or it can do the opposite. There is a user in the metaverse that gives objects or scenes to a device for a rendering at an appropriate location in the real world. And here we have a number of functional requirements that I will not introduce, and they are devices, they are metadata, the device ID, of course, as I said before, they are inherent rights, they are rights that can be obtained, and so on. Let me go back here. We have then another important element, actions. Well, action is what a process can do. So we have several things here. For instance, change is a user or a process has rights, and you want to change the rights of that process. And of course, you have to have certain rights, but then you can do it. Then you can authenticate. So you can have an item, or you can have another process, and you wanted to authenticate it. Then identify is the action whereby you take data and metadata that have been created or imported, and you transform them into items that are recognized by the metaverses. We have the action that concerns calling a service. Very important is, of course, transact. Transact is the action of a user, which is the seller, requested that a service assign the rights on an asset to another user, the buyer, and cause the wallet of the seller to be increased by a value, and the wallet of the buyer to be decreased by a value. And then it's also possible that there is a service in between, and therefore there is another amount that is passed to this other service. Then we have several important actions. And again, we're talking of functional requirements. So for instance, let me take embed. Embed is what we call a composite action, in the sense that it is more than one action. So it is, you request a service to, say, place an object at a certain place, and you get the rights to act further on this object that you have placed at a certain time. Of course, if you want to place something at a location in the metaverse, you need rights, and all this is part of the specification. So we have actions that are confined to execution in the metaverse, but we have also actions that are from the metaverse to the real world, and another from the real world to the metaverse. Then we have this other a key element that is called item. So we have, this is a long list, and I will only present a few. For instance, we have identifier, that's rules, the rights. We have an account, Then we have the activity data of a user. A user may interact with a process, or may place objects in the metaverse, or render objects in the real world. All this is captured in the activity data. We have the personal profile, social graph. This concerns the interactions between a user and another process or item. We have service access. This is interesting because let me see this discovering. Discovering is an item that you create when you want to request a service to search for an item, and you specify the features of the item. Then this is not sufficient, because then the service will package the result in another item that is called Discover Out. And we have several you're asking information about something. Interpreting, this is a very vast area in the sense that you receive, the user receives some audio, and interpreting is the service that allows you to get a sense out of this audio. Then we have a functional requirement for finance, for perception. So we have several. Of course, we have model. So the model of an avatar, for instance, we have object, we have scenes, stream. Stream is, well, it's an animation stream, for instance. This is what it is. And then we have location in the metaverse and location in the real world. Finally, we have data types. So, for instance, amount is, well, the number that represents currency units. And currency, well, it's the list of the currency that are known. And so there are other things that I'm now moving on with use cases. So use cases is a very important area, and MPAI has dedicated a lot of attention. So at the beginning of last year, we published a technical a report where we analyzed 18 application domains, and we also identified a few workflows and analyzed the workflows. Then we have, in the standard itself, we have added 9 use cases. These use cases, of course, are informative, they are not normative, and the use cases have been developed to test the specification. To do this efficiently, because it's very easy to say in a few words, oh, you have something getting here, entering a space, talking to someone else. I mean, if you want to make sure that the specification that you have is implementable and can be used to implement that specific use case, then you need to do things much more thoroughly. And this is what we have tried to do. So we have introduced the scripting language that we call MMM script. There's an M missing here. And so we have a way to indicate the processes, to indicate items, to indicate location, and to indicate actions. And because you can have half a dozen processes running, you can have 2, 3, 4, 5 locations. You can have a number of items, many users that concur. Then if you don't have a clear notation, then you get lost very soon. So this is, oh, too much. So these are the 9 use cases that we have identified. So I will just introduce briefly the virtual lecture. This is simple in the sense that we have a school manager that creates the lecture room. There are actions to be done. Then the teacher goes to the metaverse, has a lecture. Then you have a student. The student comes in, but before the student pays and then also gets the right to make a recording of the lecture. And so here we have the MMM script representation, which is long and detailed, but here we have to define it exactly. When we say MLOC1, we mean student home. That is helpful for the human to understand how what is MLOC1. And here we have a table where you see the manager calls the authoring service, creates the classroom, and then places the classroom somewhere in the metaverse. Then we have the teacher coming in, we have the student coming in, then the teacher does something more, the student does something more. Then we have, again, the manager. So all this is, this is a very simple use case, by the way, but all this can be described with this. I would like to spend more time with a use case that is very, very exciting. So we have developed a specification of a metaverse, but then we have also discovered that that a connected autonomous vehicle, by interacting with other vehicles, can create a metaverse that it's its own metaverse, which is the representation of the world where the vehicle is. So we have checked that it is possible to use the MMM script to describe the operation of a connected autonomous vehicles. Functionality profiles. So we have identified the baseline profile. This is a very basic. It's something that does not require that you register, that you have rights, and so on, because it is a friendly environment. So you can get rid of many of the quite complex technologies that otherwise are required. Then we have another functional profile. This is independent, because this one is focused on people, say, having meetings, having lectures, walking around, hanging out, while the finance profile is done for people who want to just maybe trade NFTs and so on and so on. Then we have another one that is the management profile. If you have manager, then of course you need the support of finance, but then also for registration, and more importantly, for the rights of people to do things. And finally, we have a high profile that adds just a few more technologies to the management profile. So you see that the high profile includes the management profile, and the management profile, the baseline profile and finance profile. But the two, baseline and the finance profiles, are largely independent because they address different things. So this is what the baseline profile does. I just wanted to show you a list of the actions that are required to support the baseline profile, the items and the data types that we need. The finance profile is much more complicated. The management profile is even more complicated. But as you see here, the high profile only adds 4 actions and 4 items and no new data types. So therefore, we are looking forward to working with you on this exciting MPAI project. And this you have again, the MPAI.community, which is our website. Thank you very much for your attention.